You are probably watching this video right now while wearing earphones, or maybe you have used them thousands of times on your commute, at the gym, or before sleeping. But have you ever wondered how sound travels through that tiny wire? Because sound cannot travel through a wire the way it normally travels through air. So how exactly does audio get transmitted from your phone to your ears? Before we talk about wires, we first need to understand what sound actually is. Sound is just vibration moving through the air. When something vibrates, a guitar string, a speaker, or your vocal cords, it pushes the air around it. That movement creates a chain reaction where each air molecule pushes the next one, causing the disturbance to spread outward through the air. This moving pattern of pressure is called a sound wave. The air itself is not traveling all the way from the speaker to your ear. The vibration is, but your earphones cannot send air vibrations through a copper wire. Air molecules cannot travel through solid metal like that, so if sound itself is not moving through the cable, what is inside that wire? The answer is electrical energy. Your phone does not send sound through the wire directly. Instead, it converts sound into an electrical signal. This electrical signal changes constantly. If the original sound wave goes up and down in a certain pattern, the electrical signal copies that same pattern using changing voltage. So the wire is carrying an electrical version of the sound wave. This process of converting one form of energy into another is called transduction. Sound energy becomes electrical energy, and once the sound has been converted into electricity, the signal can travel through the wire extremely quickly. Inside the earphone cable are very thin strands of copper. Copper is used because it is an excellent conductor of electricity. In simple terms, electrical energy moves through it very efficiently. When your phone plays audio, it pushes electrical current into these copper strands. Now, something important here is often misunderstood. The electrons in the wire move surprisingly slowly. They do not shoot from your phone to your ear at the speed of light. Instead, each electron pushes the next one, which pushes the next one, passing energy rapidly through the wire. It is similar to people standing in a line passing buckets to each other. The buckets move quickly down the line, even though the people themselves barely move. The electrical signal itself travels incredibly fast, close to the speed of light, even though the individual electrons move only tiny distances. And as this electrical signal changes up and down, it carries all the tiny details of the original sound wave, the pitch, the volume, and even the texture of a voice or instrument. Now the electrical signal finally reaches the earphone itself. But electricity is still not sound. The earphone now has to convert that electrical signal back into physical vibration. The part responsible for this is called the driver. Most earphones use what is known as a dynamic driver. It mainly contains three important parts: a permanent magnet, a tiny coil of wire called the voice coil, and a thin, flexible diaphragm. The permanent magnet creates a constant magnetic field inside the driver. When electrical current flows through the voice coil, the coil creates its own magnetic field. That temporarily turns the coil into an electromagnet, and because the electrical signal constantly changes direction, the coil's magnetic field changes direction too. So now you have two magnetic fields interacting with each other, the permanent magnet and the electromagnet created by the coil. Sometimes the magnetic fields attract, sometimes they repel. That constant pushing and pulling causes the voice coil to move back and forth extremely quickly. Attached to the voice coil is the diaphragm. So when the coil moves, the diaphragm moves with it. The diaphragm rapidly pushes and pulls the air inside your ear canal, creating pressure waves in the air, and those pressure waves are sound. So what you finally hear is actually air being vibrated by a tiny moving disc inside the earphone. So let's put the whole process together. Your phone stores audio digitally as data, ones and zeros. A chip inside the phone converts that data into a continuously changing electrical signal. That signal travels through the copper wire. Inside the earphone, the signal flows into the voice coil. The voice coil creates a changing magnetic field. That magnetic field interacts with the permanent magnet, causing the coil to move. The coil moves the diaphragm. The diaphragm vibrates the air. The air vibrates your eardrum, and your brain interprets those vibrations as sound. All of this happens almost instantly, thousands of times every second. This idea is actually much older than earphones. In fact, the basic principle that makes modern earphones possible comes from Alexander Graham Bell's telephone. It used the same core idea, converting sound into electrical signals, sending them through wires and turning them back into sound again. And there's one more interesting detail. If you cut open an earphone cable, you would usually find multiple wires inside instead of just one. That is because your left and right ears usually receive different audio signals. One wire carries audio for the left ear. Another carries audio for the right ear, and the third wire acts as ground, completing the electrical circuit. That is also why headphone jacks have multiple metal sections separated by small black rings. If you plug the jack in only halfway, you might hear sound in just one ear because only one audio contact is connected, but when the jack is fully inserted, both left and right channels connect properly. And this is how that tiny wire brings your favorite songs, movies, videos, and memories to your ears almost instantly.